Okay, last lesson we solved a linear quadratic system graphically, which basically meant we just were graphing a straight line, graphing a parabola, find the points of intersection. Let's do it algebraically. This is again something from grade 10, so you should already be comfortable with this. If you're having any trouble solving system equations, just do a search on the internet for solving systems of equations using substitution or elimination method. I'm going to walk through one of each, but if you need some more examples, there's so much out there. All right, so here we go. Oops. All right, so let's start by using elimination. Now, why am I going to use elimination here? You could use substitution also. Notice how everything's lined up. The y's are lined up, the x squares, the x's. So what do I mean by that? Let me write this out a little more clearly. Y equals x squared minus 11x minus 36. All right, now I'm going to line up the other one with the terms of the same degree. So we have no x squares in the straight line, negative 12x. And plus 36, right? So this would be our parabola. This guy here, he opens up. This would be our straight line. He actually has a negative slope, so he'd be going down. All right, so there we go. So let's use elimination. So what do I mean? I'm going to subtract these, right? Because what I want to do is I'm going to eliminate the y. Now you could also set up to eliminate the x, but boy, that'd be a nightmare. It's really easy to set them up to eliminate the y. Watch what happens. Y minus y is 0. X squared minus nothing here, right, is still x squared. Negative 11x minus negative 12. So to be careful here, minus negative 12, we're actually adding 12. So negative 11x plus 12 is just plus x. And same thing, we got negative 36 here minus positive 36. So it's going to be negative 36 minus 36, which is negative 72. All right, so now we have a new quadratic expression. And from this, we can determine what our points of intersection are going to be. So we've got step 1 done. Step 2, solve for x. Okay, solve for x by factoring or using the quadratic formula. So if you're having trouble factoring, and sometimes they're really difficult to factor, use your quadratic formula. This one's pretty darn easy to factor because I just need two numbers that multiply to make negative 72 that add to make positive 1, the 1 here. That means those two numbers are only one number apart, and it's going to be 8 and 9, right? And we're going to make the 9 the positive and the 8 the negative. Negative 8 times positive 9 is negative 72. Adds to make 1. Perfect. And let's solve for our two possible x values, right? X minus 8. What would make this equal 0? Right? So if we put a positive 8 in, or our other possible x value, x plus 9 equals 0, so x would equal negative 9. All right, so we have two possible x's. That tells me that we have 2 points of intersection, right? It can intersect when x is 8 or when x is 9. So we need to go actually solve and figure out what those 2 points are. So I'm just going to kind of draw a little rough sketch up here, right? So here's my parabola. We know it opens up. We know our line's going down like this. And like we just said, we know that there are 2 points of intersection. One where x is 8, but what's y? And one where x is negative 9. I really have these on the wrong side, don't I? The negative 9 should be over here. That's better. And the 8 would be over here. All right, so what's the y-coordinate? Well, it's pretty easy. We just take both of these values of x we just found and we sub them into either equation. So you choose the easiest path. What one's easiest to me, I'm thinking? I'm going to go with the linear equation. If you want to sub them in the quadratic, you can. If you want to sub them in both, just to be sure you did everything right, you can do that also. All right, so here we go. I'm just going to do it over here since I'm running out of room. When x equals 8. All right, so I'm going to sub that into equation 2 here. Here's 1, there's 2. So I'm going to sub in equation 2, my linear equation. What's negative 12 times 8 plus 36? So negative 12 times 8, add 36 to it, you get negative 60. So my first point of intersection, I'm just going to write down, here's my solution. What are the points? It's 8, negative 60. I'm just going to draw that on my diagram. 8 and negative 60. There's where that point would be. All right, and what's my second possible one? Why did I write that right there? Let's just move this out of the way. Oh, squishy, fancy. I'll move that over there. Here we go. And what about when x is equal to negative 9? Let's sub that into, I'm going to use the same equation here. There we go. Less math to do, right? Easier. Negative 12 times negative 9, add 36, and you are going to get 144 out. So there's your second point. Negative 9, 144. So that's the solution we want to give. I'll just write that up there in my diagram so you can kind of see how that makes sense graphically. Here's the solution we want to provide. These 2 possible points. So it could be this one or this one. So that would be the solution. The solution is just what points satisfy both these equations. Which points are the points of intersection, right? And there they are. All right, let's do one where we use substitution. And just to be clear, it doesn't matter to me whether you use substitution or elimination on any of these. So if you prefer one more than the other, go for it. Sometimes one works out much better than the other, so it's really up to you. Okay, so here we are again with two equations. We got another quadratic and another straight line, another linear equation. So this linear equation, I can choose to isolate x or isolate y, but it sure is a heck of a lot easier if we isolate the y. So let's just rearrange this and make this into y equals 5 minus x, or negative x plus 5. All right, so let's substitute that in. So what I'm going to do, we'll do substitution this time. Let's substitute y equals 5 minus x into the other equation. Y equals x squared minus 6x plus 9. All right, so all I'm going to do is replace y here with what y is equal to here. And what's y equal to? 5 minus x. So here we go. 5 minus x is equal to x squared minus 6x plus 9. Let's collect all the terms on one side, so I'll move everything over to the right. X squared, we're going to add x to both sides, so negative 6x plus x is negative 5x. Oops, I was going to write positive, but it's negative. And to get rid of the 5, we're going to subtract 5 from both sides, so 9 minus 5 is 4. Now, once again, I've made these easy to factor. That's not always the case, right? I just didn't want to drag on forever doing the quadratic formula. We've done that in grade 10. We've already reviewed it this year in our videos. But beware, if you get to this point and you can't factor it, use your formula. This one's another easy one to factor because two numbers that multiply to make positive 4, that add to make negative 5 are negative 4 and negative 1. All right, so we set both of these equal to 0, right? So x could equal 4. It's one of our possible x values, and x could equal 0. So in both cases today so far, we've got two possible x's. Now, sometimes that's not the case. Maybe you factor it and you only get one out, right? When would that happen? Let me just write down a scenario. What if we factored and we got this, right? X minus 5 times x minus 5. This is different, but right, they would be the same thing. In both cases, x minus 5 would equal 0, so x would equal 5, so we'd only have one root, right? So that's how we could get one root. What about how we'd get no roots? Well, if it's impossible to factor, and if you use the quadratic formula, and while you're doing the quadratic formula, remember how it's negative b plus or minus the square root of b squared minus 4ac divided by 2a. If the value underneath that square root is negative, that's not a real number, which means we don't have any real roots. So that's how you could end up with no roots at all, right? All right, so there we go. But we got two roots. Let's go sub it back into one of the equations. It really doesn't matter which one you sub it into. I'm going to sub it into this guy because, boy, is that easy. Y equals 5 minus x. So here we go. When x is equal to 4, right? Well, y equals 5 minus x. 5 minus 4, that's pretty simple, is 1. And when x equals 1, right? Well, y equals 5 minus 1. So y equals 4. So that's pretty simple. We have 4, 1, and 1, 4. Nice little coincidence there. And there's our 2 points. Now again, if you're graphically wondering what does this look like, well, our parabola, the a value is positive, right? So this opens upwards. There we go. So it'd be opening upwards. When I write it like this, my slope, the number in front of the x, is negative, so I know my line's heading downwards. So this is just a very rough sketch, right? And there's my 2 points. One is 1 over 4 up, and the other one would be 4 over 1 up. Very, very rough, quick sketch. All right, we're going to do one more very quick example. Okay, so in this case, what if we just want to know how many solutions there are? Sometimes we don't care what the solutions are. We just need to know, does this line hit this parabola or not, right? If we're modeling the path of a projectile and the path of something else, an airplane or something, will they connect, right? Will these things hit each other or not? All right, so in this case, we're not going to basically find the points of intersection. We're just going to find out if there are any, right? So it basically starts out exactly the same. You have to use substitution or elimination. Just to point out, this is a horizontal line, right? And this other guy is our parabola. So A is positive, so it opens up. So I'm going to draw a quick sketch of what this could look like. We got a parabola, and we got a straight line. Now, where could that straight line be? It could hit, or they're all straight lines, sorry. We have a horizontal line. It could hit at 2 points, like that. So we might have 2 points of intersection. It might just hit the vertex and hit it at 1 point, like that. Or it could be below and have no points, right? All right, so let's check this out. I'm just going to use substitution method here. And here we go. So I'm just going to set the two equal to each other. So I'm just say y equals 2 here and y equals this here. So I'm just going to set these equal to each other and go, all right, 2 equals x squared plus 4x plus 7. Collect all my terms on one side. X squared plus 4x, we're going to minus 2, which gives us plus 5. Now, you could try to factor it, but that would be actually finding the roots. How do we use the discriminant? So remember what the discriminant is? That's what we just talked about in that last question here. Remember when you're using the quadratic formula, negative b plus or minus square root of b squared minus 4ac, the discriminant is the number that we get underneath the square root symbol. So if we get, this is the question, right? If b squared, let me just write this down here, minus 4ac, if we get something greater than 0, that's when we get two solutions, right? If we get something equal to 0, that's when we get the one solution. And if we get something less than 0, a negative, well, that's impossible. So that's when we get no solutions. So that's what we're going to do. A is 1, B is 4, C is 5. And I'm not going to do the whole quadratic formula. I'm just going to do the discriminant. B squared minus 4AC. All right, so here we go. 4 squared minus 4 times 1 times 5. That gives me 16 minus 20, gives me negative 4. So the discriminant is a negative value. That tells me that we have this scenario right here, right? We have the scenario where we will have, it's less than 0, so we have 0 solutions. So I'm going to state, you know, how many points of intersection do these intersect? The answer is they intersect at no points. And that's it. And I proved it with my discriminant at no points. And then if we want to be clear here, why? Because, you know, when you're asked to justify, your answer should basically say because. Because why? Because b squared minus 4ac, or the discriminant, right, is less than 0 for this scenario. Okay, there you go. Done. All right, that's the end of this lesson. Try the questions out and check out the next